networks. In Unit 1, we are having topics such as Introduction to Artificial Intelligence Applications, Problem Solving Agents, Search Algorithms, Uninformed Search, Heuristic Search, Local Search and Optimization Problem, Adversarial Search, Constraint Satisfaction Problem. So, Unit 1 as well as Unit 2 will be deals with artificial intelligence, and Unit 3, 4, 5. These are all deal with machine learning terms. First of all, we are moving for uninformed search strategies. So, it will be also be called as blind search. It has general purpose search algorithms. They don't have any additional information about the state or else a state or a space, search space, other than it can able to have how to traverse the tree in a data structure. Types of uninformed search, there are six classifications over that. Initially, breadth first search, second one is depth first search, third is depth limited search, fourth is iterative deepening DFS, fifth one is uniform cost search, sixth one is bidirectional search. So, first one, breadth first search. It is the most common strategy and most efficient strategy. It is implemented with the help of first in, first out queue data structure, that is FIFO queue. It will search the breadthwise in a tree or a graph. It is an example of a general graph search algorithm. So, whenever we are having BFS algorithm, it will start the searching from the root node and it will traverse or expand the data towards the successor node. Once it will reach the goal node, the iteration will going to stop. Next one is BFS algorithm. In the step 1, place the root node inside the queue. In the step 2, if the queue is empty, then stop and return failure. If the friend node of the queue is a goal node, then stop and return it as success. Step 4, remove the friend node from the queue, process it and find all its neighbors that are in ready state, then place them inside the queue in any order. In the step 5, go to the 3, and in the step 6, exit that particular loop. For an example, we're just going to consider this particular tree as an example for BFS, that is breadth first search. So this tree consists of A, B, C, D, E, F and G. These sort of elements. A is called as root node and D is called as a goal node. That is going to assume. So initially in the step 1, we have to place the root node in the FIFO. That means in the queue. So this queue consists of the initial node called as a root node is A. Inside a queue, we have to place that one. Then at the step 2, now the queue is not an empty one. It has two child, that is B as well as C. And moreover, A is not our goal node. So you have to move to step 3. What is this step 3? You have to remove the friend node from the queue. That means the friend node is A. You have to remove that A and you have to place that neighbor of these two. Neighbor of A is B as well as C. So we have to place C and B here. Now, right now, the friend node is B, right? So if my friend node is B means it has two child, that is D as well as E. Once it will traverse, the neighbor nodes are D as well as E. Currently, my friend node is B. So, fine. Here, my friend node is B. It has two child, D as well as E. So, once it will reach the goal node called as D, it must stop the iteration and it will encounter the final status D, E and C. This is called as breadth first search. It must start from the root node. It will reach the goal node through a successor elements. This is called as BFS. Advantages of BFS, it will provide a solution for any problem or any solution exists. It will provide a unique solution. For more than one solution, BFS will provide minimal solution with lesser number of steps. Demerits or disadvantage, it must require lots of memory and lots of time if the solution is far away from the root node. Second algorithm we are moving is DFS, depth first search. Please remember, BFS will traverse as an horizontal manner. DFS will traverse as a vertical manner. So, DFS is also be called as recursive algorithm for traversing a tree or a graph data structure. It starts from the root node and follows each and every path to its greatest depth node before moving towards the next path. Here, this DFS is implemented using stack, that is LIFO, last in first out, but the BFS implemented with a queue, that is first in first out. Algorithm for DFS: enter the root node on the stack, do until the stack is not an empty one, remove the node if the node is equivalent to the goal, then stop the iteration and push all the elements in the node inside the stack. Then last step, you have to pop out the element. Kindly consider this particular tree as an example for DFS. It consists of 5 nodes S, A, B, C and D. So initially your friend node or initial start node will be this S, right? From this S you have to start. So in the stack, please remember, as I already told, this will be in terms of stack element or a stack data structure, last in first out. Whatever the element which we are going to push last, that particular element will be popped out first. That is called as last in first out. So I'm going to push my initial element or else initial root node as S inside the stack. So S will become the root node. And in the second step, mark this particular S as already visited node and put it onto the stack. Explore any unvisited adjacent node for this particular S. So we are having 3 sort of adjacent node A, B and C. Usually in DFS, we are going to follow an alphabetical order. So we have to place A after this S or above this S. Sorry. So A is become right now the top of the stack. Then after this A, this is my root node currently, and we have to search whether any unvisited node or not. Here, S as well as D. Which one is unvisited? This D is called as an unvisited node. So D can be called as an unvisited. D is placed above this A. Then right now consider D as my root node and we have to compare any unvisited node. We are having 2 nodes, B as well as D. Sorry, B, C as well as A. 3 nodes we are having. So which one is unvisited? B as well as C, both are unvisited. But we have to follow an alphabetical order. So for here, after D, B will comes, right? Then for this B, any unvisited nodes you are having? No, there won't be any unvisited node. So after this one, you have to pop out the values from top of the stack. So currently B will be popped out. Once B will be popped out, you can able to have this D alone. So for this D, if this will be considered as a top right now, whether it will have any unvisited node? Yes, that unvisited node is called as C, right? So this can be placed as in case of the top of the stack. So this is the stack structure or stack data structure for DFS. S, A, D and C. So this particular algorithm hold good for DFS, depth first search. Advantages of DFS: it costs less memory space, it will reach at the goal node in less time period. The time required for this DFS is less as compared to BFS. Demerits: there is no guarantee of finding the goal node. Sometimes the states may also enter into an infinite loops. These are all the demerits of or disadvantages of depth first search strategy. Thank you.